Buongiorno, buongiorno a tutti. Hello, good morning, welcome everyone. My name is David Escher. I'm a journalist and analyst specializing in the additive manufacturing industry. We cover, research, study the industry, and we report on it daily via our website, 3D Printing Media Network, and my company, 3dpbm.com. At 3dpbm.com. We're here today with the European Association of Machine Tool Industries and Related Manufacturing Technologies, CECIMO, at the world leading fair for the machine tool industry, EMO Milan 2021. During this conference, we will provide some of the latest developments and on the additive manufacturing sector. I'm sure you've seen some of the stands at the fair, especially the hybrid solutions, so subtractive additive manufacturing solutions in light of the post-COVID era evolutions. We will provide some insights on increasing the levels of flexibility, agility, and productivity in your organization by leveraging these technologies, listening to some of the experts at implementing, studying, and researching these technologies. So without further ado, I would like to introduce Mr. Stuart Lane, Sales Director of Renishaw France and Chairman of the Additive Manufacturing Committee at Sesimo. Renishaw is one of the first companies that from the overall machine tool and metrology industry invested into additive. So thank you very much, and we will hear. I'll leave you the microphone for the opening address.
Thank you very much, David. Thank you for that very kind introduction. I hope you're equally as kind to us in your journal as well. Thank you very much. My name's Stuart Lane. As David mentioned, I am the sales director for Renishaw France, based in Paris. And I also, for 3 years now, have been chairing Sesimo's Additive Manufacturing Committee. I'd like to welcome everybody here. Thank you for your attendance. Thank you for letting me in your beautiful country. Even a few months ago, I really did wonder whether I was going to be able to attend this event. And I'd like to say that I'm extremely pleased to be here today. And it's great to see so many of you in person as well. A little bit about Sesimo before we start talking about today's subject. Sesimo is a trade association. It's a company that's been in existence since 1950. It's based in Brussels, and it represents the machine tool industry, interfaces with government in Brussels, and it also represents the needs and the interests of the additive manufacturing community, and especially in subjects such as innovation, technology, use of technology deployment, and finance. So that's a little bit about us. It wouldn't be a presentation today, and it wouldn't be a conference today if we didn't speak a little bit about COVID and the impact that COVID is having on business. And we're not out of it yet, as we know, and we're still seeing the effects of the pandemic and its impact on businesses such as yours, other macroeconomic effects as well, such as Brexit, which I wasn't going to mention today, but I feel I have to. And we're starting to see some real impact in terms of supply chain. We were talking about onshoring and bringing manufacturing back to Europe even prior to the pandemic. Those conversations seem to be increasing now, looking at the geopolitical situation, what's happening a bit in the States, what's happening a bit in China. So local manufacture is becoming more and more important, and we genuinely believe that additive manufacturing has a strong role to play, almost unique role to play for business in terms of being able to give you a more flexible and local manufacturing capability. The pandemic, as we know, has had a big impact on our society and our business. It's impacted free movement of goods, services and people, which is of course a founding pillar on which Europe and the European Union have been based. we've seen a divergence in terms of companies' policies and restrictions and how we can move between the countries. I know coming to Italy, the requirements are different to France. That's put pressure on business, particularly those people in the service sector. And we're also seeing an increase in disruption of supply chains. It's been a bit of a wake-up call for companies, and companies we are now seeing are questioning their supply chains, their strategic dependencies, and looking increasingly for reliability and flexibility domestically. And as I mentioned, I think our sector, the additive manufacturing sector, is uniquely positioned to support companies in this change in strategy. And that brings me on to today's subject, which is hybrid manufacturing. We've spoken a lot at Sesimo, at conferences like this, about AM in particular, additive manufacturing in particular. Today we're talking more about hybrid technology being the combination of additive and subtractive technologies. A lot of people see these technologies as discrete. They are not. They work hand in hand, and when you combine the advantages of both, you get better outcomes. We're going to talk a little bit about that with the speakers and the panel that we have for you today. Sectors that we're seeing that are picking up on this technology, well, surprise, surprise, aerospace, surprise, surprise, automotive. But when it comes to hybrid technology, the sector that we think is really going to grow is in terms of repair and service, taking existing parts, adding material to them in the specific areas where you need, and then machining them back to give you that repaired, complete component. There are clearly cost benefits, but there are also some disadvantages as well. It's expensive to invest in, although prices are coming down. There's a lack of skills, people to run the machinery, people to design the processes. There's a lack of standardization, which is inhibiting take-up in the more regulated industries like the aerospace industry. But these things can be overcome, and at Sesimo, we are working with European government to get support for finance, to get support for skills and education, be that retraining existing staff or bringing new staff into your workforce, and also financing R&D projects to help get this technology off the ground. I'm on my last bit, and then I'm going to hand you over to our first speaker today. Just to summarize, we think this is a great technology for future business needs. We think that we're in a unique position. We think that it's going to become more cost effective. We think it's going to become easier to invest in. We think it will support you in a green transition of your business, particularly in the repair sector. And I look forward to seeing our presenters today to get your views and your applications of this technology in action. Thank you very much. I hope you enjoy it, and I'll pass you back to David. Thank you.
Thank you very much for that. Very clear introduction and opening. Just a couple of notes. We will have a panel after the speakers, so please keep your questions for the panel session. Also to the speakers, please please remain within the 15 minutes time frame, so we can all get to the end of the presentations. So without further ado, I would like to introduce the first speaker, who is Eleonora Azzeni, Associate Professor in Technologies and Manufacturing Systems at Politecnico di Torino. I would like to add that besides, I think it's very important for the industry to grow, besides having an association, Also having, the next very important step is having education to learn and understand these processes, which are very complex. So thank you very much, Eleonora, for being here.
Thank you. Okay. So thank you for your introduction. First of all, let me present shortly myself. I'm professor at the Politecnico di Torino and especially in the Integrated Additive Manufacturing Center at the Politecnico, so where we developed the research about these technologies. My presentation today is about the potential and challenges of hybrid manufacturing, so integration of additive and subtractive methods. Okay. Yes, I think you can read. So basically, additive manufacturing has gained a lot of attention by industries for the potentialities of these technologies. For instance, the possibility to create very complex parts. The possibility to increase the complexity means that we can optimize the part, reduce the weight of the component, and reach an added value on the component. That is also interesting from the economical point of view. Additive manufacturing, as was introduced before, is a flexible technology, is a digital technology. So what you create as a three-dimensional model is produced by the machine. So we have the physical replica of your idea. And this is disruptive, and this meet the mass customization requirements, because you can change the model, you can change the part, you can build different parts on the same job. We can have a customization of components. We can have components with multiple functionalities in the same part, avoiding assembly of different parts. So this is the consolidation, the reduction of number of parts. And we have the added value. This is the most important characteristic of additive manufacturing components. But there are also some drawbacks. And today we discuss about basically the surface quality. Because when we want to combine subtractive is to remove material to obtain specific properties on the surface. The part is typically rough. The roughness is higher than conventional machining, especially. We can compare with casting. And the tolerances are larger than other subtractive methods. So, to improve the aesthetic quality, tribology characteristics, or to have closer tolerances, better surface quality, we need to apply surface finishing treatments. And surface finish, you can see in the picture three different metal components obtained from right to left: powder bed fusion, electron beam melting, directed energy deposition. So the differences are very evident. Moreover, we must apply finishing processes if you want to improve the fatigue performances, because the surface roughness can be a problem. So what type of finishing technologies? So basically, the same techniques used in conventional parts can be used in additive manufacturing. So considering metal parts, basically, we can apply media blasting, shot peening to improve the quality of the surface and also obtain a compression state on the surface. That's another characteristic. But sandblasting, basically, it depends on the system, but basically is performed manually by the operator. So we have a loss of uniformity on the surface treatment and a long time. So there are also mass finishing systems, mechanical, by using abrasives in a tank, so the part is surrounded by these abrasives. This is faster, but again, we have some problems in accessing, especially internal surfaces, internal features. It was the previous slide, okay. For internal features, we can use also abrasive flow machining. So we use a viscous liquid with abrasives inside to improve the surface of channels, for instance. Other methods are laser ablation. And this is interesting for laser machines. So we have a laser in the machine. We can combine different lasers. And so perform building and polishing in the same machine. Some researchers are going on this topic. And chemical finishing, but we use an etchant. So we have the problems related to the safety hazard and the sustainability of the process. Electrochemical, but again, for internal features, we use an electrode, and so accessibility problems, or interesting also the super finishing, isotropic super finishing for mass production is another interesting system. Okay, but by these technologies we can improve the aesthetic appearance, we can gain tribological functionality, but if you want precision, we want to meet the close tolerances, to meet the requirements of the design, we need subtractive methods, traditional subtractive machining. And in case of machining, we have different solutions. So in general, when we talk about hybrid machining, it's the combination of additive and subtractive to obtain this strict part quality. A possibility is to perform in sequence the operation. So first we have the production by additive, and then we move to another machine, a CNC machine, and we perform the machining operations. Better is it is a 5-axis machine for the complexity of the geometries. But in this case, the same characteristics of additive manufacturing that make this process very attractive, the complexity of the part, the optimization, etc., becomes a problem when machining, because we have to fix and hold and fix the part in the machine, so we have reference surfaces, datum points, and the problem is similar as what happened in casting. The low stiffness, we reduce the weight, the part is optimized for specific loads that are different than loads applied by machining, and probably we have difficulty in reach the surface, thank you, the surface by the tools. So, we have also the possibility to alternate. This is a solution. So first, the geometry, the simple geometry is produced by machining. This is cost effective. Then we add the additive part. The difference is very visible. The machine part is very small. The rough part is the feature added by additive, and then probably we have to machine to improve the surface. So we can alternate. But most challenging is the combination of the two processes, additive and machining, in the same system. There are several commercial systems available, especially based on directed energy deposition. There are some solutions also for powder bed fusion, but it's quite more complex. By that, we can create, to add the part, add the features to a substrate, an existing part, and without repositioning, we can machine the same part. and so perform the surface finish. And in this case, we can combine the advantages because by additive manufacturing, we can add to a substrate, we can repair component. The repairing application is one of the most interesting application. We can also change the material, apply multi-graded material possibilities to improve the strength on the surface, backlanding. And also for thermal application, apply some material that has a higher conductivity, only where needed. So reducing expenses, but also difficult to work or costly materials. By machining in the same system, we avoid the repositioning, we increase the precision of the operations because there are no errors due to the change of the machine, the transfer to another machine, repositioning the part, so alignment errors. And there is also the possibility to machine the surfaces when they are built. So internal features are created, machined, and then we add other material. So we can access to internal features that at the end of the process will be inaccessible. So these are all benefits, but there are also many challenges about these processes. What is the best sequence in additive and subtractive? We have to decide. How to define the toolpath by using computer-aided manufacturing softwares, because when we add material, we could have a collision, so the software have to consider also this aspect. And what is the effect on the substrate? Because there are thermal effects. We add material, we have heating, and it's possible to have deformation or changes in the microstructure. So also this aspect should be considered. And in the case of dead deposition, dead machining, if you use lubricants in machining, we have the problem on reusing the powder. So what is the powder capture rate? Also this aspect should be considered. So these are challenges that have to be faced in next activities, next research to make the process more efficient for industrial production. So I conclude this with this sentence, very interesting premise, but we are just barely begun to exploit its capabilities. So thank you for your attention.
Thank you very much, and that was perfectly timed, by the way, so thank you for that too. So we looked at the benefits of an association in additive, the benefits of education, what the benefits of education can be, and then now we need to look at the benefits of developing the technologies and the processes in the machines. And I would like to introduce for that, to speak about that, Florian Voigt, AM Process Chain, head of Sales and Application for LaserTech SLM Technology at DMG Mori. He will discuss challenges in connected processes and unsolved problems in the field of education. What I wanted to say is that I think it's very interesting that Mr. Freud has an expertise specifically in the SLM, mainly in the SLM processes. And as we saw, hybrid technology started with DED, but also now we're seeing how also the powder bed fusion SLM type processes can also benefit from hybridization. So without further ado, I give you the microphone.
Yeah, thank you so much, ladies and gentlemen. A big pleasure to be here. Unfortunately, Eleanor, our presentations have not been aligned up front, so I don't know what to add in addition. So everything was well explained. It's really tough to set up this kind of hybrid manufacturing. So we do this by nature within DMG Mori. But what I want to focus also in addition, what is in between. So you showed a nice picture of having the SLM machine connected to a CNC, and then you end up with a finished part. So our daily business shows a lot of different challenges in between. So this is what I want to stress out in my speech. Talk a little bit about the drawbacks for sure. So don't get me wrong. Additive manufacturing is one of the nicest technologies if it comes to future production. No doubt about it. But there is a lot of things you have to think of if you want to end up in a nice part. So I don't think that I have to talk too much about DMG Mori. You're all well known, #1 in the world if it comes to machine tools, different locations all over the places. And in addition, we have not only machine tools. So advanced technologies is one of the nice parts of DMG Mori, because we benefit from all the know-how within the group if it comes to CNC machining. And you really nicely explained about the problems if it comes to clamping and the forces during the CNC process. So this is something which is really a extreme benefit and one of our, let's say, core businesses. Some of these pictures you have already seen, so again, not well aligned, but in the end we talk about the same topic. So for sure you will see some pictures in some of our speeches. These are the parts you well know. Nice, shiny, fancy, a lot of beneficial features integrated, and this is what you expect. And to a certain extent, it's also our fault that we show all the time these parts. So if you come to exhibitions, you will always see nice, shiny, sometimes also finished, meaning in our case, machine parts. And this is the expectation of most of our customers. So when I talk to prospects, to customers, they have this in mind. And I just told it up front, I want to give you a small, it's an insight. It's just a small story. Our management changed, and we have now, again, a new managing director, a strong background if it comes to CNC machining. And we got a requirement from a customer, a potential customer, to print a nice wheel carrier, as you can see it over there. And the question was, can we build this part within the specs? And you might see this small sign up there. So we just stand up there, all the speakers, and I was asking who is aware what this sign means. And I want to place the same question here. Do you know what the sign means over there? Has someone an idea? For sure, a metrology expert from Renishore, he could answer the question. But we had to look it up. It's free-form tolerance. So the entire part, also the not machined areas, must be within this tolerance. And the question was quite easy. So you can expect the same from your boss. Can we produce this part within the specs? And our application engineer, really an educated guy, a lot of experience, was unable to answer this question. No chance to answer this up front. And this was quite funny. So it took us over 2 months in the end to answer this question. I just want to give you a small insight about this internal discussion. So most of the people think, this is what I said, you just print it and you get your part right away. So no headaches, no problems, nothing post-processing wise. But that's, sorry to say it, not true. You have to think about how you get to your finished part. And again, all the people tell me all the time, I just showed the most ugliest, the nastiest parts on the exhibitions. And that's not to, let's say, mess around with additive manufacturing. Don't get me wrong. As I said, it's an insane technology. But this is what you get out of a 3D printer, especially if it comes to metal. You have your part there. It's welded down with support structure to your base plate. This is what you get. Ugly surfaces, as you explained. Nothing nice. So especially my colleagues, which come from CNC machining, they always say it's so insane, nasty, so ugly. No one want to touch this part. For sure, the benefits drive this technology, integration, lightweight, and all the stuff. You heard it all up front. But then you end up with a part like this, and the problem starts. So hybrid solutions, as I told you, is in our DNA. But the problem is how to set it up. Hybrid in our mindset doesn't mean that it has to be in one machine. The process chain, and you already told our audience, there are a lot of different opportunities to set up this process chain. Especially the one where we start with a machine part, where it is, the part must not be that complex and all this stuff. And we add just additively material where it has a benefit. This is, from our perspective, maybe the most beneficial process chain in the end. But again, we set up the process chain, another 3D printer up front, additive, but in the end, it's the same thing. But this is what you have to keep in mind. Surface smoothing, heat treatment, how to cut it from the base plate, how to post-process in areas where you have no access with a machine tool, and then, in the end, how to clamp it, how to machine it on your CNC machine. So, expectations meets the reality, and this was also internally what happened within DMG Mori Additive. So we set up this process chain, but in the end, we forgot about distortion. So it's a welding process. We are heroes in generating chips. You don't have to ask DMG Mori how to generate a chip, but how to weld something is a total different approach. For sure, we as DMG Mori Additive, we have some ideas. We also have some background knowledge, but in the end, it came down to the problem how to optimize the part, maybe also for additive manufacturing, do some analysis if this part is still meeting the specs, design additional features, as you showed it up front, how to clamp this part. There is no chance just to print it as it is and then try to fix it somehow in a machine. You have to add material in addition. And then we did a simulation. Okay, so you start with your CAD0 model, no distortion, nothing at all, and then you simulate it. And in the end, you see the part is completely gone. You won't even find it in a CNC machine by touch probing it. It was really a nightmare. So we had to do several calculations, pre-deform it, and in the end also support it differently after the pre-deformation. Set it up again, do the calculation back and forth. So within this several loops, we ended up within the specs, being in this freeform tolerance of 0.2 millimeters. But in the end, okay, how to freeze this geometry afterwards. If you just detach it after printing, it's already, it's again distorted. So you have to make up your mind also about heat treatment, and heat treatment processes also maybe specified to the needs of the part and the material. So again, remember the question, can we produce the part within the specs? I don't know what kind of people you have in your company, but this is in the end something you have to have a genius. This is the part we expect. Nicely done, perfectly. And, oh sorry, I just missed out here. You need this genius guy, know-how about build job preparation, all the process simulations, microstructure analysis maybe in addition, as a material scientist, then he should know how to operate our 3D printer and also how to machine the part in the end. Just ask this one question to one people, to one guy within your company. You will need, you will need an expert group in the end to answer it. So in the end, it took us 14 days. Everyone is thinking, okay, 3D printing is so fast and rapid prototyping and all this stuff. But if you really want a part, which is not a bottle opener or a pencil or something in the end what can be used in the industry, you have to make up your mind also and set up all these processes and also, if possible, yeah, a seamless software platform for it. So in the end, as I said, the part is done. A lot of things had to be removed also manually. So some kind of artists, well known if it comes to dental applications. There you have this kind of skills available. So in the end, you will always have a challenge to reach all the features and to machine it. But we succeeded, and you can see also the nice and finished areas and also where we just removed the additional material for clamping. I want to show you also another approach which we had internally. So this was an internal task of our colleagues from Gildemeister Drehmaschinen GmbH. So we set up our Robo to Go Head, and this is the approach how it should take place also in your companies. Think in functions and not in restrictions. So these guys set up this nice topology optimization up front where we had to have material and all these channels and all this stuff. For sure, we had to cover it instead to get rid of all these chips and that they will end up there. And we made it also a little bit stiffer. This piece, as you can see it here, came down from over 140 parts to 1 in the end. And the tolerances, 16 times better than setting it up piece by piece by piece together, and with all these assembly issues, maybe also tightness problems and all this stuff. So this was an eye-opener for our colleagues in machine tool industry. We all think about race cars, aerospace, and all this stuff, but there are so many applications out there in general engineering which have a need for additive manufacturing. And if you set up your process chain in the right way, you think in functions, not in restrictions, you will end up in these kind of nice parts, as you can see it over here. For sure, in the end, if you ask DMG Mori, it always comes down to the question how to do it. Yeah, how to set it up. So we printed 4 of them on a normal base plate, as you can see it, and then we tried to separate them somehow, bring it to a machine tool. For sure, this can work if you have easy geometries, but we are not DMG Mori if we don't have an answer to this also. So we integrated also a 0-point clamping system in our 3D printer, and that's the way how to bring parts back and forth between the technologies to end up really in a hybrid process chain. And again, a funny story about this. You see the parts here not positioned in the middle of this 0-point clamping areas. A CNC specialist directly knows why. So again, we set it up in the middle, handed it over to our experts in CNC machining, and he was asking if we are really working in the same company. I was not aware, but for sure, kinematics of the CNC machine has also an influence how to position the part. If we place it like you can see it here on one edge, it's way easier to access the areas without generating some kind of crashes or interference between the machine tool and the part itself. So again, something, a lesson learned on our end, keep a CNC guy close to your additive expert in order to make sure that you end up in a part which can also be machined on a CNC machine. With this 0-point clamping system, I think we have one of the key questions answered, how to bring it back and forth without a lot of tolerance issues or problems finding the parts. But again, this was also a lesson learned. One example in the end, this is from the medical industry. Setting up a part, this one is in titanium, in the way that you just machine up front where you need the nice surfaces, tolerances and all this stuff. place it afterwards in the machine, and add material where it's needed. In this way, we could avoid all these nasty support structures and all this stuff, and showed additional benefits. Because normally you weld, I just want to stress it out again, you weld the same material of your part to your base plate. So a titanium part needs to be welded on a titanium base plate. And after that, you just, I don't know how, saw it away, but you have to machine the base plate. So it's a wear part. With this setup, we could do this base plate in stainless steel. And because the part itself is the base where we weld on top, there is no wear at the base plate. So thinking in process chains means taking care of a lot of different aspects. And we have specialists within the group. So we have seen this over several projects. Therefore, we set up a special team within DMG More called DMG More Additive Intelligence. And these guys will help you all the way down. If you face issues, as I explained it in my speech right now, don't hesitate to come to us, ask, and we would try to set up the most beneficial process chain for you, no matter if it's SLM or DED in the end. We will find the right solution for your future and production and the nice parts which we all expect in the near future. So thanks for the chance to talk to you here up front, and I'm more than happy to answer your question afterwards in our panel discussion. Thanks.
Thank you very much for that. That was very, very interesting. Let's also, I will ask you later if after that long process of understanding of the first example you made, if the next time it goes faster or not, but I will ask you in the panel. So let's look a little more about the additive part of the hybrid technology equation. I'd like to call Paolo Calefati, Head of Additive Manufacturing and Innovation at Prima Industrie, for a presentation on mechatronic and photonics as key technologies for the development of laser machines for AM of metal components. Paolo, you have the mic.
Okay, thank you for the invitation. Thank you to Sesimo for this opportunity and to everybody to be here. My name is Paolo Calefati. I'm the head of the Prima Additive division. That is a new division of the group of Prima Industrie. Probably nobody knows very well Prima Industrie for the additive manufacturing. So I prepared the presentation just to introduce briefly the reality of Prima Additive. And yes, talking about hybrid technology, I totally agree about what Florian told before about that. We are very conscious about the limitation of additive. That's for this reason that we speak about the mechatronic and photonics that could be the key technologies to solve many problems of additive and to help also the integration between additive manufacturing technologies and milling. By the way, it should go? Okay. Yes, as you can see, just to introduce briefly the division, Prima Additive is the newest and also the smallest division of Prima Industrie. You know that the other two divisions are Prima Power and Prima Electro. The first one is very focused on sheet metal working machinery, and the second one on laser sources and electronics. Prima Additive is the division who makes the additive manufacturing machines. Here a short story about Prima Industrie. As you can see, Prima Additive is just born in 2018. And okay, some number about Prima Industrie. I think that you can see also this number on the website, so we can go very fast. Then, okay, our presence to the world. We are in more than 80 countries around the world. And okay, talking about additive, yes. Talking about additive, additive is a social trend at this moment. And just talking about the trends that could be addressed to additive manufacturing technologies. And I just tried to recap some of these cases. And then I would like to speak more in general about each of these cases in order to understand and to let you know which is our think about additive manufacturing and why additive could be profitable. But there is, in my opinion, something that should be done for the additive technologies for the problem that Florian showed before, because it is not easy. So our focus is improving the additive manufacturing machine maturation. So to introduce new laser sources, to introduce new features of this machine that could improve the additive manufacturing process. It could solve certain problems like deformation, like material properties, and so on. So just talking about 4 sectors, we got experience in these 4 sectors in these 2 years of our activity in additive. And we will talk about new materials development, aerospace, automotive, talking about functionalization, and so high volume application. The direct energy deposition that we know very well as a technology, and then an application about circular, and some application for oil and gas. Then just to show you what is additive today. This is a very academic graph, no? Everybody of you probably knows this graph very well. And as you can see today, the additive manufacturing application is just 1% probably of the total additive manufacturing market. Now, Sesimo is the machine, Industrial Machine Association. They know very well that the total market of the additive manufacturing machine today probably is less than 1% of the total market of the industrial machine. It means that there is a break-even between geometries, functionalization, and cost, and volumes, and so on. And sometimes also hybrid technology born for this case, no? Because, okay, let's match additive technologies and milling, and everybody of us, all of us have the temptation to say, okay, a bit of milling, and then I can have the same components with the decreased cost, and so on. It's fine. It's a way to do that, no? But the point is that, no, we have to improve the state of art of the additive machine. And this is our approach. And this is our added value in this market, to be honest. So, okay, these are our 2 new technologies that we are going to introduce to next Formnext. We introduce new laser sources, different wavelength, also to work different materials, but also to improve the material properties. But also we improved the status of art of the optical devices in order to have some stress relief approach during the process, to have a different wavelength in order to use the right laser source for that kind of material. And also we developed some machine platform that is very flexible to be used. Okay, this is our powder bed fusion family. We have 3 platforms, 150, 250, and 400. You can visit us. You can see 2 of our platforms in this exhibition. And we are going to introduce this machine that is very flexible. We are mixing, so in this sense, we are also hybrid in this case, because we are mixing infrared laser and green one. And then we can select the proper laser to work different material. We have a different monitoring system, and then we also improved the capability of the connection of this machine with the rest of the factory through the 5G interface and the real-time control of the machine. Why green laser? Then you can see here that for copper, for instance, green laser is a very good point, because we have a better absorption, we have a stable process, and the material properties are very quite improved. Oh, sorry. Okay, here you can see, then we have some space application, but also oil and gas. We can reduce the process to reach this kind of tools, but we are also decreasing the cost. We are improving the geometries of the part, and also the roughness is much better in this case. But these are the application focus on small volumes, high cost. They are quite okay for additive at this moment. The green laser allow us to work the pure copper and to reach probably the material property as a bulk. Here we are going also to develop the multi-optics. Our next develops for next year is to introduce up to 16 laser for machines. You can see here a very typical business case in automotive, that is the heat exchanger. This exchanger has 3 different stages with 3 different geometries. It means that this component could be optimized, and the efficiency of the components could be improved up to 30% more. The problem of this component is the cost, also because the volume should be very high. Today, the desired cost for the automotive is 40 euro per component, but with the dual laser, we can reach it, we can produce it for 400 euro. So it's very expensive. Improving the number of the laser up to 16 with the platform 600 for 600 that we are going to have in next 2 years. The idea is to reduce the cost down to 80 euro per components. It is something that is higher than 40 euro, but it is accepted because the component is functionalized. Then talking about the direct energy deposition, that is our technology that usually it is meshed with the milling. We are going to introduce our Real DD. Real is an acronym. It means real-time adjustment of the beam during the direct energy deposition. It means that we have a very high dynamic beam shaping, and then we can change, we can adapt the beam size of the laser beam in real time. So we can be very precise, or we can be very productive. But the point is that during this process, with this beam shaping, we are going to improve also the material properties, because we are making some stress relief during the process. Just an example here about this case. This is a tool for agriculture. Usually this tool is post-treated chemically, and the cost is 300 euro. The standard DD process could reach this component, could produce this component for a cost of 600 euro, but we can improve the mechanical properties with the real DD without any post-treatment, and we can be faster, and then we can have this component produced for a cost of 400 euro. And no chemical process, of course. So, just in conclusion, improving the additive manufacturing aspect, working on mechatronic leverages, and hybrid is one of them, we can reach a new target of AM. That is the profitability. And then we are opening 2 new areas. The area on the right is the gap that we are covering for the competitiveness of the additive manufacturing. On the left, we will keep the delta cost for the products made in additive manufacturing, but the customer is available to pay it if these will be functionalized or they could be reused. So the most important part is let's work on the integration of the machine with the milling machine and the other processing. Let's work for the integration of the additive in the traditional industrial context. But the most important part is that we should keep working on the improvement aspects of the additive manufacturing machine, because we have to solve the problem that Florian showed before. This is the point. Okay, now just to say you that we are in this exhibition at the booth 5, C10, and then we are waiting for you.
Thank you very much for that. And so we've seen a lot of different processes. We've seen a lot of different hardware technologies. We've seen a lot of different studies that need to be made of the part. And well, then it's time for all these parts to talk to each other and to work together. So my next speaker will talk a little bit about how we do this with software. So I call Francesco Benasso, pre-sales consultant at Siemens Digital Industries Software, for a talk on Siemens Holistic Digital Twin to industrialize additive manufacturing.
Thank you very much, Davide. So very nice to be here in AMO Milano 2021. Again, I'm Francesco Benasso, pre-sales consultant and portfolio developer for Siemens Digital Industries Software. And today we're going to talk about our software solution. But before that, let me briefly introduce Siemens and what Siemens does in this field and in additive field. So it is very probable that you know that we are we are the biggest industrial conglomerate in Europe, but most people do not realize that we are one of the top 10 companies for what concerns software development. For additive manufacturing, however, we are not just a software vendor, we also use this technology intensively. Many business units of Siemens are using this technology. For example, Siemens Energy, they have been one of the early developer of this technology and early adopters, and as well now they are using it very intensively. They are printing gas turbines components. And I'm saying all of this because this is one of the key differentiators of our software solution, because all the know-how we gathered from using the technology has been driving the development of our software, teaching us exactly what really matters in this technology software-wise. So our understanding right now is that one of the main barriers to industrialize additive manufacturing when it comes to software, it's an uninterrupted, fragmented workflow. And what I mean is that most of the company we talk to, well, they are using multiple software solutions and vertical software, and this software are not talking together. And this means that for industries such as aerospace or medical, it's incredibly hard to trace the process and to certify it, because there is no guarantee, there is no way to manage data transfer every time you go from one software and the following one. And for all those companies and all the sector, for example, automotive, in which certification sometimes is not key, in any case, such a process is incredibly inefficient. It simply takes so much time to go from designing your component to print it, only because you keep losing data and your data chain is disrupted. This is why, as Siemens, we try to solve this issue, allowing you to leverage what we call a holistic software solution. And when I say so, I mean that we provide you just one software environment in which you will be able to find all the tools you need to go through all the additive workflow. And when I say so, I mean that you will be able to design your component, to optimize it. You will be able to, simulate the performance of your component in such a way that it will be optimally designed. you will be also able to manufacture your component, whether it is hybrid or other sort of technologies, and you also will have the chance to simulate your process from a thermal perspective, right? And finally, you'll have the chance to directly integrate with machines and manage all the quality issues. For companies and sectors, again, like aerospace and medical, this is key to being able to easily certify this sort of process. So I've called it holistic. When I say so, I also mean that we are covering the main technologies, whether it is about powder bed or, well, planar technologies such as powder bed or binder jetting, as well as multi-axis technologies. And this is going to be the focus for us today. But of course, we cannot do that all alone. Our strategy is to partner with the best machine tool builders in the market. So if in the audience, is there anyone who is working for an OEM? Please get in touch with us. We are sure that we could have a very interesting business conversation on how we could benefit from each other. But okay, let's deep dive in what actually our solution is capable of. So yeah, so you may have noticed that I haven't mentioned a specific additive technology so far. Yeah. This is mainly because we provide support for all the main technologies when it comes to hybrid technology and deposition technology, whether we are talking about whether we're talking about direct energy deposition or wire arc or big plastic industrial machine which are depositing material. So I said we have this very nice workflow, and what is exactly relevant for multi-axis deposition technology? Well, at first you want to design your hybrid part. Then probably you will want to understand whether this part is exactly manufacturable. And then after that, you can engineer all the manufacturing strategies, whether it is hybrid or it is just purely additive. And after that, you want to simulate your machine, whether we are talking about a kinematic simulation of your machine, trying to understand whether there are some issues related to, I don't know, out of reach or collision, but also the thermal process, the additive thermal process. And this is key in this case, trying to understand upfront if there will be any issue for your production. Finally, of course, you can integrate with your machines, and you can get your part. So I'll try to talk a little bit about these topics process-wise, and the first topic is, of course, component design. So we provide one of the best-in-class CAD tools, Siemens NX. You can design your component, optimize it with the most advanced technology right now, which are available on the market. We call it generative engineering or other sorts of optimization. What I want to stress here is how important and relevant having just one software solution between your design department and your manufacturing department. And here I want to ask you a question. How many times did you have to redesign your components because there were some sort of issues downstream? How much time, maybe for manufacturing, and how much time did you lose because you had to recreate all the manufacturing strategies simply because there was some issue from a design standpoint? Well, with our solution, this will be solved because all of the features would be easily updatable with a push of a button. And yeah, this is a great value for this kind of industries. But okay, let's deep dive in the following topic, that is whether you design and manufacture your components, or you receive the geometries from your clients. At a certain point, you have to ask yourself, but am I able to create this component with the technology I have in my shop floor? Well, we can help you to understand that. We offer a series of tools for manufacturability validation, so you can understand whether your component is thick enough or it has or it fits in your machine, or it has the correct overhang angles, and you can do that easily. And you can, as you can see in the photo, you can create it, and you can color your components where you have some issues. The next topic and the next step when you have to develop your component, it's usually trying to prepare it for manufacturing. We call it decomposition phase. So we are trying to split our object in different features, and which can then be deposited. And you can do that simply in our software with the powerful and flexible CAD tools you already have available. And this is usually also a good moment for fixing all those issues related to manufacturing. You can add a material here and there, or you can tweak the draft angle so that you won't have any surface quality issues. Well, the next step, finally, we talk about deposition. So in our solution, you can leverage the best of our 3-axis and 5-axis operation. And here I would like to stress a little bit the importance of 5-axis operation in depositing, whether we are talking about direct energy deposition or plastic deposition, and again, wire arc. So 5-axis operation are not there only for allowing you to being able to create a very complex shape, such as heat exchanger vanes or turbine blades, but they are really the key to get a very nice superficial finishing. So, and this is key in this sort of technology, especially when it comes to finishing these components. So basically, you are able to create more constant thickness walls in your components, and when it comes to finishing, it's simply you will have to remove less material. It will take less time, and again, you'll consume less tooling. So it's simply key to drive down the cost. But well, you may wonder, what sort of operation can we do? What sort of geometry can we create? Well, we provide a great deal of flexibility in our solution. So whether you have to deposit a very simple shape, and you can deposit that with slides that are parallel to each other, it doesn't really matter if they are parallel to your build plane or their angles. Well, gravity does matter, but from a software standpoint, of course, you have this sort of flexibility. You can deposit material on a cylinder or some revolute shape. You could come up with basically with an additive lathe, but you can also deposit material on a very complicated 3D shape with our additive freeform operation. Finally, we provide great support for all those coating operations which are so needed when it comes to repairing, and as well as when you have to, coat a certain surface with continuous continuous fiber. So this is really helpful in this case. Well, finally, we start to talk about hybrid. So in our software, hybrid means that in the same environment, in the same software, in the same file, in the same graphic window, you will be able to start to subtract material and to introduce subtractive operation. And this gives you a great deal of flexibility simply because you have a huge amount of possibility in terms of manufacturing strategies. So you could go from a deposit mill deposit approach in which you deposit a bit of material and you finish that. And this is great because basically you can forget about undercuts, because undercuts are not going to be there when you mill your components because they haven't been deposited yet. Or you can go, and this is usually very helpful, is if you have a hybrid machine with both deposition and milling functionalities. But you can also go, if you have multiple machines, you can possibly go for a full deposition program, and then you go directly to finish your components. Well, now we talk about simulation. When you have defined all your strategy, you will wonder, can I do this? Does my part program have any issues? We not only provide the capability to simulate the kinematic of your machine so that you can understand whether there are some collision, whether there are some out of reach if we are talking about a robotic, or singularities if we are talking about a robotic solution. But we also provide you the ability to simulate the additive process. And this is, and we got to remember that after all, the additive process is a hot process. There are a lot of issues that could happen in the meantime while you're printing. There could be detachment from the build plate. There could be warpings. There could be wall collapse. And this is something that you would like to know upfront, so that simply you can go towards a zero scrap rate. Last but not least, we provide great automation. So if you're interested in PLC or CNC, driving them with Siemens software is, of course, allows you to reach a great synergies between the two solutions. And this is also the finish. We are at the end of the process. We have our component fully printed. But this is also the finish of my presentation, and I would like to leave you with 3 main takeaways. The first one, Siemens sells software, hardware, and has the experience to help his customer and his prospect in industrializing additive manufacturing. Second, that our software, it's a holistic software which will help you to cover not only one technology, but the entire workflow from design to manufacturing your components. That said, thank you very much for your attention, and have a nice demo.
Thank you very much. And we are now at the end of our presentation. I would like to call the speakers on the stage for our panel session. And we will have the opportunity to answer any question that you may have. We've seen a lot of products, a lot of hardware, a lot of technologies. So if you can come to the stage. Yeah, sì, bisogna.
Maybe I'll go on that side here.
Perfetto. Thank you. Oh wow, that's very loud. So. If you have a question, please just raise your hand. I'm sorry, I had a couple of questions written down, so just in case. Thank you. Please go ahead, raise your hand, and I will come around with the microphone. Okay. So I will take some questions from the audience, and then we can you can also, if you have anything to add to your presentations, you're also welcome to talk. Oh, thank you very much. If you can introduce yourself and ask the question.
So, yeah, my name is Michael Harsch. I'm an application engineer in hybrid additive manufacturing at Matsura Europe GmbH. And I have a question for Mr. Florian Feucht. First of all, I want to say I really enjoyed your presentation in particular because yeah, you clearly showed some of the challenges that are being faced with additive manufacturing, with hybrid additive manufacturing, and with the whole process chain. And I agree 100% with what you have said and what you have shown. And
thanks.
Yeah, for you being head of sales and application, I would like to know, yeah, what are some kind of strategies how DMG or you yourself is trying to improve or accelerate the adoption of that technology, hybrid technology in the market, because with all these challenges, the barrier for yeah, establishing such a disruptive approach for many customers, especially in highly regulated industries, is quite high because many of them, they have a stable process. So that's question one. And question two, do you think we already have a completely sellable product process chain with hybrid AM, or is this still a business development phase at the moment?
Oh, hopefully I can remember all the questions. No, for sure. Thanks for the questions, and you're 100% right. So in the end, you asked for our approach, how to sell this, how to improve the possibilities in the market. That's the reason why we set up additive intelligence, DMG Mori additive intelligence. So what we faced in the early days was that, as you explained it also, this hurdle we generate and all the threats we pointed out were not really helpful to sell equipment, especially in high regulated areas, or even to our, and that's the base of our customers, to the SMEs. In the end, with this consulting approach, no one wants to talk about consulting in the end, but with our additive intelligence, we had the chance to overcome most of these hurdles, to set up the process once for the customer as a kind of learning for him, and then transfer this together with the machinery to his site to end up in a, first of all, stable ramp-up phase. And then in the end, the customer, if they have the technology close to their fingertips, they adopt very fast, to be honest. The second one, if we have already all this in place, yes and no. That's it's a really tough question. For sure, we put all the pieces together, trying to solve the issues. We heard a lot about also the seamless experience within Siemens. And this is one of the key enablers, to be honest. We see this also for our customers. But in the end, you have already installed processes at your customer. And if you try to force him to buy a new software just because he added one additional machine is also quite a challenge. It's a tough task. So yes, we know what to do, but setting this up customer specific is still a challenge. I hope this answers your question.
Thank you. Yes, and by the way, if you have anything to add, you are welcome to add. Do we have any other questions from the audience? I have a question from before, which is, so you showed us how it takes 14 days for that one particular. My question is, once you did that once, the next time, are those processes in place so that you can do it faster, or is it totally different for every application?
No, not for every application. In this case, it was a special part, and to be honest, in the back, it was a safety critical part for a race car. So we had to do additional double checks, and this took us, in the end, 14 days. For sure, you will be faster if you have done it once and everyone knows how to do it, because then you can have this kind of learning curve already done. And this is also a big benefit for these kind of early adopters like Siemens. Yeah, they did it in the early days, also with the equipment which was maybe not that stable, as we heard it from my colleague here. But with these learnings, you can improve for sure this time period. And in the end, the second one was way faster, 3 days, and then it was done.
Thank you very much. Do we have more questions? I want to ask you. So we saw many different types of hybrid approaches. You mentioned briefly that there are some technologies, especially DD, but also PVF, that do it in the same machine. What could be the most immediate benefits and maybe or maybe challenges of doing it in one machine? And because also Matsuura just spoke, maybe you can refer to in particular the challenge of PVF, powder bed fusion, and subtractive, if you can expand on that a little bit.
Okay. So basically, in powder bed fusion, we have that the part is surrounded by the powder bed. So performing machining while the part is built means that we produce chips that goes to the powder bed, and we have also some movement of the powder surrounding the part. So we have to take care. So combining the same machine is quite more difficult than in the DAD process. DAD process is another problem which is related, as I said before, to the lubricants. If we use the lubricants, the powder, the unused powder, cannot be so easily recycled or reused. So this is another challenge. But the main benefit is that we have access to the feature while it is created. So without moving the part from one machine to another machine and removing the unused powder and increasing the time, because we have also the time to transfer the part, so reducing productivity. By having the combination of the two systems on the same machine, we can solve this type of problems. Maybe the solution could be also to have two separate areas in the volume of the machine, one for additive and one for machining. But in this case, it's only the platform which translates. So this could be a solution.
Okay. I also would like to ask you, so we saw, you mentioned correctly, you know, that to have two different solutions also within one machine, but how difficult is it to add, for example, your system, your DED systems and or powder bed fusion systems into a work? Do you feel that it has to be integrated into a workflow, or do you think at this point, for the types of applications that you use, the machines can also be more standalone for some current applications?
But the integration is very easy at the end. I think that the most critical aspects regard the software, of course, and the safety probably, no? Safety aspect for the installation of the machine, different system, powder management, or laser management. In case you are just installing, you are just upgrading some machine, some milling machine with our head, laser head, and so on. But the point is not that. I think that what is important is having a system that is able to manage all different aspects of the production. So for instance, what Siemens before said is important. This kind of approach. So to see everything from a unique software tool is very important. Under this point of view, the integration, the hardware is not very difficult. It's not very difficult.
Thank you, and that was actually you introduced my next question. So how hard is it to make the Siemens software work with? So I know DMG Mori has its own software platform for the machines, but also for automating many parts of the workflow, and all machines have their own software. All metrology systems have their own software, all subtractive systems. So many different software that need to talk to each other. How hard is it to have the Siemens software talk to all these different platforms?
Well, the answer is incredibly simple. It's incredibly easy. No, jokes aside, having just one software means that you have you open one software and you'll be able to do everything in just one platform. And you don't have to talk with those software. So we provide a functionality of all the other software you can have. So from this standpoint, it is pretty easy, yeah. And the point here is how our solution can do that. And again, we we do that by partnering with companies. So I think that the partnership with DMG Mori, it's a very good example for this. We started in 2016, if I'm not mistaken, or in 2016 was the first machine, the first product available.
I still remember the first discussions. It was at the NEMO show also at that time, 2013.
Yeah, 2014.
Oh, wow.
Yeah. I was starting university back then.
Oh, now I feel really like an old guy.
But yeah, I mean, only when we partner with this sort of player that we really are able to absorb the know-how from the field. And what is another question that you may also have is why should they do such a thing? Well, I suppose there is a very general concept, and is the following: the best software you have, the more successful you are. But if you are a machine tool builder, why do you want to have your customer adopting a certain software solution? And my answer probably to this sort of question is, well, if your customer is successful, it will saturate that machine, it will print at 100% of its capability faster, and then it will come back to you for asking for a new one.
Absolutely. That's a good point that you made, that this partnership goes back to 2013. And I remember also, when DMG Mori entered in the SLM business. And so what I wanted to ask you is how has the AM industry evolved since then? Have you seen a lot of progress, and where do you see it in 5 years from now?
Oh, also tough to answer. So, to be
obviously,
honest,
with referring to your type of technologies.
Yeah, sure. So, to be honest, we started, as I mentioned, DED somewhere 2013, the first ideas, and we took over Realizer 2017, beginning of 2017. So within this 4.5 years now, we see now the more or less 4th generation of our SLM machines, and DED has also, I think, 2, 3, maybe also 4 generations and different types of machines. So there's a lot of progress going on in this short period of time. If you compare this to the machine tool industry, where we have knowledge over, let's say, hundreds of years, more or less, it's incredible. It's really awesome what has been achieved in the meantime. What we have also heard, that we have to think, maybe also into future products and what kind of materials will be needed for this. And again, we will see great innovations, maybe with combined laser sources and all this stuff, but also, as we heard on the software side. In the end, it's one thing, and this is what I wanted to stress out also: keep the people who have to run the machines. Keep these people in mind. Don't put so much stress on some small shoulders in the end. And this might be one of the hurdles in the future also. So I think the machines, softwares, and all this thing will be easier for sure in the end. But the challenges also will be raising in the same way like the improvements of the machinery and the software.
Absolutely, thank you. And go ahead.
Can I add something else?
Of course.
Yeah, so when we talk about hybrid manufacturing, we have in mind mostly metals. But right now in this MO, there is something happening, which is something I think it's worth mentioning. That is that there are some machine tool builders that are presenting hybrid system with polymers. And according to me, and according to what we can see right now in the market, that this sort of technology, hybrid, so plastic plus machining, it really have the chance to disrupt some industries which hasn't been touched so far by what we have now in mind as hybrid technology. This machine right now, can find a very interesting application for the marine sector, for example. They are made for printing molds, and well, in the future, maybe in 5-6 years, probably we will see in the yacht industry a lot of molds printed with this sort of technology, and maybe also some parts which fits in the machine. So when we talk about hybrid, it's not just metal. There is much more, and we honestly think that this sort of technology will have the chance to disrupt business much more than what we have seen so far.
Absolutely, and I have to add that in our composite study, we also highlighted how this by the way, these are some of the largest machines for composites, additive and subtractive, and we also highlighted this as one of the biggest opportunities in the evolution of the composites, chopped fiber composites industry, absolutely. Go ahead.
Yeah, sorry, I just want to add also maybe something what we heard. So we are also driven by technologies. So we love machines, we love software and all this stuff. But what we face in the industry is a lack of educated people. And this goes back to the universities. And also, it's also a tough challenge for all of us to set up these kind of process chains in a way that normal people can operate it in the end. What's the point in setting it up so complex and so stressful in the end that only maybe PhD students will be capable of operating these machines? So I hope that it will not take decades again and generations of professors until we end up with the right people to operate these machines and to think in functions and not in restrictions. And this is also, I think, a great task to the universities.
So I agree, absolutely. The education, training of operators, but not only, also the business who make decision about to buy or introduce additive manufacturing production. So this part is a key point. So we have courses in our program at university in engineering, masters, second-level masters, and courses for industry.
Have you seen a greater interest in additive manufacturing over the how much, in what way?
The growth is exponential.
Okay.
Yes, so the interest is very, very high. The need for skilled not only operator, but engineer and other members of the staff is very, very high.
And by the way, Paolo, you launched Prima Industria, the additive part, I think also about 4 years ago or so. What are the challenges that you see in starting, entering the industry and starting this type of business?
More in general, to be honest, yes, we launched the division officially 3 years ago, 4 years ago. But we started with the research program much before than 2018. Prima Industria is a strange company, no? In terms of technology developments, because we were able to join our capability making machines with our capability making components, laser sources, numeric control, and electronics. So for us, it was a sort of technology integration. No? Just for the direct energy deposition, for instance, it is just an upgrade of our 3D laser cutting technology. For the powder bed, we started from scratch, and we participated in a new startup called 3D New Technologies, and we started making this experience in this market, co-designing the machine, the powder bed fusion machine, and developing the new one with this startup. At this moment, we are launching a Prima Additive is a project, is a spin-off project. We will become a separate legal entity. And we have a good growth plan for the future.
Thank you. And if we don't have any more questions from the audience, we can close the panel now. Thank you very much for your contributions. Thank you for the speakers. Thank you to everyone. We now have a closing remarks from Philippe Gertz, Director General at Sesimo. Thank you.
Thank you. Yeah, it will be not a lot of remarks, rather just closing words. I would like to thank the moderator, Davide, and also all the speakers for being present at this edition of the International Additive Manufacturing Conference here at EMO Milano. It was fascinating to hear all these updates on hybrid manufacturing and the potential applications in all these different industries. In the last years, we saw that there are really growing interest from industry, but also from policymakers in hybrid manufacturing and its applications to support mainly the competitiveness of different strategic sectors in Europe. Today's discussions proves that the sector can indeed play a crucial role in many companies' production lines, and this really in different industries. However, I think that the deployment of this technology has still room to improve over the following years. The question is, of course, how far are we now from considering hybrid manufacturing as a real viable solution to bridge the gap in any company's production chain? Many sectors should take the chance to test the benefits of hybrid manufacturing and see these technologies as an opportunity to drive their business into new industrial ecosystems. Now, at Sesimo, we believe that hybrid manufacturing has an important role to play in increasing the industry competitiveness and supporting more circular business models. Therefore, we will use the information collected today and continue to discuss how to promote the development related to this technology and address any regulatory, technical, and market barriers that could impact the sector's market uptake. It is clear to us at Sesimo that in order to support the sector's growth, it will be essential to work on an innovative, friendly policy framework, increase the number of dedicated standards, promote the development of training and education in this area, and provide also financial and technical support to those industries that wish to implement changes in their production chain.